Hey there, welcome to a video discussing 6.2 day 2 for solid systems equations using the Gauss-Jordan method. So the stuff that we did on the previous day all had one solution, right? You had something for x, something for y, something for z, and it was those exact answers. And when you have two equations and two variables, that's two lines. So when you have lines here, that's two equations with two variables. But when you have three equations with three variables, those are planes. And that's what we have in example one. And so, yes, you have all these planes that are out there and they intersect at a particular point. Now, sometimes you get no solution or infinite solutions. And let me show you how that's going to look. So let's, and this should be a pretty short video. There's just a couple examples and a bunch of 4 problems you'll do. So let's take a look at this one here. So we got, to make an augmented matrix of 5, -4, 3, -4. That 4 looks like an 11. Let's fix that. -10, 8, -6, 8, 15, -12, 9, -12. Now, one thing you'll notice is that these are multiples of each other, right? If you multiply, for example, if I do a 2r1 plus r2, here's what's going to happen. So 2r1, of course, is going to be 10, -8, 6, and -8. If I add all that to the second row, everything's going to cancel, which is definitely a problem when everything cancels like that. And I mean, if you want to change the third one, go ahead. You could have said 3r1 plus r3, or sorry, 3r1 minus r3. Let me fix that. 3r1 minus r3. And then you could do, that would be then 0, 0, 0, and 0. So what happens in this case is that everything cancels, just kind of like when we saw with like system with two equations, two variables, all the variables cancel and get 0 on the other side. Obviously, you have a true statement, so you have 0x plus 0y plus 0z equals 0. And likewise, this third row. So really all we're stuck with now is 5x minus 4y plus 3z equals -4. And there are going to be infinite possibilities that satisfy this. I can't think of it off the top of my head, but well, actually I could. Let's say x were 1 and y were 1. You have 5 minus 4 plus 3z equals -4. So 3z equals -5. So z is -5 thirds. There's going to be infinite possibilities. I could let x and y be other numbers and z be something else. So in this case, we would say there are infinitely many solutions when this happens. Because you're just stuck with one equation. And if you made up random numbers for x and y and solve for z, great. But you could do that for a lot of different possibilities. So because you're just stuck with just one plane, and the other two planes cancel out. And here's another one. This is a 2 by 2 equation, 2 variables. So let's make an augmented matrix. 3, 1, 2, 3, 1, -7. And if you want, you could do r1 minus r2. So you keep the top row as is. The bottom row becomes 0, 0, and 9. Well, of course, the second row makes no sense because you have 0x plus 0y equals 9. 0 does not equal 9, clearly. So as happens, we say there's no solution because you want to be a statement that's not true. And I believe, I haven't worked these 4 problems up. I believe they're all going to kind of work in the same fashion. So I'll try to make the answer key sometime later today and share with you guys. But go and work on it, talk to you, help each other out. And that's what we'll do for the rest of the class. All right, well, be well, and hopefully I'll see you guys on Thursday.